Hello everyone. In this presentation, I will be discussing about embedded processors. We'll be covering introduction to processors, basics of embedded processors, what are the different types of embedded processors, and difference between its types. Now before jumping to embedded processor, let us first understand what a processor is. From the name itself, you can make out a processor is something that would process something. So, a processor is the heart of an embedded system. What it basically does, it takes the input, processes the data, and then produces the output. It has two essential units. The first is the program flow control unit, that is the CU, and the next is the execution unit, that is EU. What a control unit does is it fetches the instructions from the memory, and the EU uses that fetched instructions from the memory and has ALU, due to which it processes the fetched instructions. So CU and EU form the two main essential units of a processor. One fetches the instruction and other processes and executes that instruction with the help of ALU. There are different types of processor. First one is general purpose processor GPP. The other is application specific system processor, that is ASSP. And the third one is application specific instruction processors, that are also known as ASIPs. I will not go into the details of ASSP and ASIPs. Embedded processors are part of GPP, and so we'll be focusing more on that. Now coming to the main topic of our presentation, that is what an embedded processor means. An embedded processor is a microprocessor that is specially designed for an embedded system. Now see, embedded systems are very small, they require less power, and they draw less power from the source, and hence they are very cost effective. There are two main types of embedded processors, that are ordinary microprocessors and microcontrollers. I'll be discussing each of them now. Microprocessor. A microprocessor is a single VLSI chip having a CPU. In addition, it may also have other units such as coaches, floating point processing arithmetic unit, and pipeline units that help in faster processing of instructions. So all these coaches and floating point processing arithmetic unit help in the faster execution of the process. Now earlier the clock frequency was of the order of around 1 megahertz, but now with the advancement of technology, the clock frequency we have now is of 2 gigahertz. This is the simple block diagram of a microprocessor. The next type is a microcontroller. Now a microcontroller is also a single VLSI unit. It is also known as microcomputers, but it has limited computational capabilities. Why it has limited computational capabilities we'll discuss when we see the difference in between them, but it has higher input output capabilities. Microcontrollers are particularly used in embedded system for real-time control applications. So now let's see the difference, because both of them sound quite similar. So now let's see what is the difference between a microprocessor and a microcontroller. A microprocessor is multitasking in nature. Now you can perform multiple tasks at same time. For example, you can, as written here, you can listen to songs and write or edit text at the same time. While if you are on a microcontroller, you can perform only one process. That is, either you can write or either you can listen to song. Both the processes cannot be performed together. Now RAM, ROM and input-output ports and timers can be externally added and vary in numbers. So you can customize a microprocessor. While in microcontroller, they cannot be added externally. They are embedded together in a chip and are fixed in numbers. You cannot modify a microcontroller, whereas you can modify a microprocessor. So that was the reason that we said that it has limited computational capabilities. Now designers can decide the number of memory or input-output ports. But in microcontrollers, fixed number for memory or input-output microcontrollers. External support for external memory and input-output ports make a microprocessor based system heavier and costlier. Now see, if we are adding anything externally, we are going to add cost to it. So microprocessor is not that cost effective, but yes, it is a little costlier and heavier, whereas microcontrollers, as it is fixed, you cannot modify it nor can add externally anything to it, are lightweight and cheaper. So cost wise, microcontroller is more efficient, and as we can externally add things, they require more space and higher power consumptions for microprocessors, whereas for microcontrollers they require less space and less power. So I hope I have made the difference between the two clear, and this is it from the presentation. Thank you.